change those numbers in real time. So that's more of an interesting party trick, but let's talk about some of the commercial realities of this. So one of the things that this drives that's very foundational in our offering is this concept of making every asset on the grid, whether utility-owned or consumer-owned, what we call grid location aware. And when we use that term, it has nothing to do with physical location. So when Carl pulled in this morning and he parked his electric car over here at Market 14, it's interesting to know that there's an electric car plugged in at Market 14. It's useful to know that there's now an electric vehicle with this much battery capacity in this current charge state that just plugged in on the C phase of lateral 17 of feeder number 5 of substation number 2. Utilities can make meaningful use of that information and do bidirectional communication, leveraging that growing fleet of vehicles is one example. Most utilities will also tell you that they have a very rich GIS database knowing where these physical assets are, but because of decades of compounded documentation errors, M&A events, things of that sort, line crews not necessarily firing away as the blueprint dictates, they don't know what's connected to what. They may not know what feeder your home is on, certainly not what lateral or what phase. So one of the first things we do with any new utility is we literally go out and create a schematic map of their grid, which then can be made up with that GIS database. This now enables a number of other offerings. Fault isolation. When your home's sitting in the dark after an outage, right now the only way the utility becomes aware of that is when you call them and tell them that. Because we're able to now sense any changes in a variety of electrical characteristics on the grid, and we've got all these little breadcrumbs so we know where it's happening, we can tell them before you maybe even notice that your power is out, where it's out, why it's out, what device has failed. Now instead of rolling multiple vans to triangulate, they can roll one van preloaded with the right replacement part. Reliability goes way up. Demand side management. It's somewhat counterintuitive to ask an industry to convince customers to use less of their product. So yes, they will do it, but only under regulatory pressure. Who in their right mind would convince their customers to cut back? So rather than saying, we have a problem, we have a peaking problem here in Metro Denver, if I as a utility can isolate that at a more micro level within the grid, and now instead of shutting down everybody's air conditioner for 15 minutes, I just shut down the ones on the relevant portions of the grid, I've satisfied my peak shaving, but I've impacted my revenue as little as possible. I can also now have some real-time feedback so that I can tell which homes are going to be calling for electricity at 3, 3:15, 3:30. What's the ambient versus the target temperature? Is that load going to sustain for 7 minutes or 7 hours? Just the arbitrage savings that utilities recognize from being able to optimize their need to buy 24-hour ahead, week ahead energy futures becomes a very compelling financial benefit. Grid security. We're working with DHS and a number of the big system integrators in that realm. Because our sensors are able to sense anomalies in electrical characteristics as well as the direction of propagation, size of propagation, like the metaphorical motion detector within the grid, being able to spot cascading failures before they lead to regional outages. For plug-in vehicles, one of the reasons there aren't more vehicles on Carl's right now is there's a lack of public access charging infrastructure. Now, there are a number of technologies that are starting to come on the market, these smart charging pods, and they work very well. It's like having to go capitalize a vending machine or an ATM for electricity in every potential parking space. Remember 30 years ago when you wanted to make a phone call? You had to wander around town and look for the corner phone booth. Go to the corner phone booth, stand in line and wait your turn to make your call. It's kind of like that. We've taken an approach where we have a device called a VIM card. It serves a very similar function to the SIM cards in every one of your cell phones right now. It's just a portable billing identifier. Take your electric car, plug it in any dumb old outlet. All the smarts is centralized upstream of the utility, just listening. Someone plugged in the car, Whose account is it? What are your boundary conditions? I'm going to commute to work at 7 in the morning. I'm going to come home at 6:30. I need to be at 63% minimum charge. Never violate those conditions. Pricing parameters. Here's the price at which I'm willing to buy power. Here's the price, Mr. Utility, at which I'm willing to graciously sell it back to you in the afternoon. All that is now a portable identifier that just roams with the car. We do this with one common device called a PowerTagging module, or PTM. It's about the same size as your iPod. We connect this device at different levels of the grid by mating it up with different coupling circuits. Not terribly unlike the way you can take your iPod and amplify it to different levels. Plug it in your clock radio, plug it in your home theater, bring it over here to the Pepsi Center, and really crank it up. All we're doing is using different coupling circuits to do different levels of impedance matching, voltage matching, protection circuitry from transients coming in across the grid. On the back end of that, we have an eGrid database to do things like, you just come back one. When you plug in your electric vehicle, you're inevitably going to start roaming across service geographies from one utility to the next. How many of you want to get 6 different bills for 37 cents? The cell phone industry has conditioned us as consumers to get used to a very high level of convenience. You just want to get one bill. I want all of my Excel bills. If I wander across a state line or up into the mountains into a rural co-op, I don't want to know about it. When I go spend 99 cents for a new song on my iPod, I don't care whether the royalties are going to Sony or RCA or BMG. Apple takes care of that. In like fashion, we've got mechanisms for doing all of that cross-utility reconciliation, so you as a consumer have an easy time. It also allows them to do a number of other customer optimizations for demand-side management, setting those usage profiles, and so on. So then we're using this across all different points of the grid. You know, we could be talking 35 or 70 kV in a substation, obviously 12-volt circuit in a vehicle, standard line voltage for controlling your air conditioner, your hot water heater, and maybe several hundred volts for all of this distributed generation that's inevitably going to start to impact the grid very dramatically. And we're just applying those tags, and again, we're communicating bidirectionally over the grid. So with that, to get back to Peter's proverbial elephant, I don't think we would enjoy a very pleasant view. We would be basically inside of this elephant. And, we're going to be touching its central nervous system. And like the grid today, that elephant's a lot wiser and a lot smarter than it might appear at first glance. And that central nervous system already exists, and it goes to all points of the elephant. Why not leverage what we already have versus a number of other technologies that are relying on secondary carrier networks, cell phone modems, or broadband, where if we wanted to make that elephant dance, we'd have to start by drilling a hole in its head and mounting an antenna and outputting sensors on every muscle group. The nervous system's there. We're just enhancing the smarts of that signal crossing the synapses. We can get that elephant dancing pretty quickly and inexpensively. That's it on this.